Okay, let's get right into it. If you're studying for the SIE exam, you know those bond questions can feel, well, a little tricky. But what if I told you that you could answer some of the toughest questions about bond yields just by picturing a simple seesaw? That's what we're going to do today. We're going to build that mental model so you can walk into your exam feeling totally prepared.
Does a question like this make your head spin? I mean, you've got 4 different yields, the bonds trading at a premium. Where do you even begin? Well, stick with me, because by the end of this, you'll be able to answer this in seconds. No complex math, I promise. First, we got to build the foundation.
Everything, and I mean everything we're about to cover, rests on this one single idea. If you get this core relationship, the whole bond market just clicks into place.
So here it is. This is the fundamental bond seesaw. You have to think of it exactly like this. When one side, market interest rates, goes up, the other side, the price of existing bonds, has to come down. They always move in opposite directions. It's a law of nature in finance.
So you might be asking, why does this happen? Well, it all comes down to good old-fashioned competition. Imagine you own a bond that pays 8%. Suddenly, new bonds are being issued that pay 9%. Your 8% bond is, well, it's less attractive now, right? To sell it, you'd have to lower the price to make it competitive. And that, my friends, is interest rate risk in a nutshell. This inverse relationship is the engine that drives everything else we're going to talk about.
Okay, so now let's build on that basic seesaw. We're going to add our 4 key players: the coupon rate, the current yield, the yield to maturity, and the yield to call. This is how you're going to absolutely ace those exam questions. We have to start with our baseline, our point of equilibrium, right? This is a bond trading at par. All that means is its market price is exactly its face value. Usually that's $1,000. When this happens, our seesaw is perfectly flat, no tilt. And check this out. When a bond is at par, there's no discount, there's no premium to worry about. You pay $1,000, you get $1,000 back at the end. So the coupon rate, which is what the bond pays every year, is the same as your current yield, your yield to maturity, and your yield to call. Everything is equal. 8 equals 8 equals 8 equals 8. Easy peasy. But, bonds rarely stay at par for long in the real world. So let's say market interest rates have gone up. What happens to the price of our bond? You got it, it goes down. We now have what's called a discount bond, trading for less than its $1,000 face value. The seesaw has officially tilted. And just look at what happens to our yields. When the price is down, the yields all go up. The coupon rate, you'll also hear it called the nominal yield, that's set in stone at 8%. It never changes. But because you're paying less for that same income, your current yield is higher. Then your yield to maturity is even higher still, and yield to call is the highest of all. They climb in that exact order every single time for a discount bond. Okay, but why is the yield to maturity higher? This is the aha moment. Let's say you buy this bond for $900. You're still getting your annual interest payments, but you also have a built-in $100 gain just waiting for you at maturity when you get the full $1,000 back. Yield to maturity accounts for that extra cash, spreading it out over the life of the bond. That little bonus bumps your total return up past the simple current yield. So, if YTM is great, why is yield to call the king of the hill here? Well, it's all about speed. You get that same $100 built-in gain, but you get it back sooner if the bond gets called early. Getting that bonus over, say, 5 years instead of 20, that just turbocharges your annualized return. It's the same profit in way less time, which means a much higher yield.
All right, let's hit the reset button and tilt the seesaw in the complete opposite direction. Now let's imagine interest rates have fallen. That makes our 8% bond look super attractive, right? So its price goes up above that $1,000 par value. We are now dealing with a premium bond.
And just like you'd expect, the yields now tilt the other way. When the price is up, the yields go down. Our fixed 8% coupon is now the highest yield of the bunch. Because you paid more for that income stream, your current yield is lower. Then yield to maturity is even lower, and yield to call bottoms out as the lowest of all. It is the perfect exact reverse of the discount bond. The logic here is just the mirror image of a discount bond. If you pay, say, $1,100 for this bond, you are facing a built-in loss of $100 when it matures because you're only getting $1,000 back. Yield to maturity has to account for this loss. So it spreads that $100 hit over the life of the bond, which just systematically drags your total return down below the current yield.
And finally, why is yield to call the absolute lowest in this scenario? Because it's your worst-case scenario as an investor. Realizing that $100 loss in just 5 years instead of 20 is more painful, financially speaking. The loss gets accelerated, which makes your annualized return even lower. It's the fastest way to lock in that loss, so it's the lowest possible yield.
So, we've seen how the seesaw tilts for both discount and premium bonds. Now let's put it all together. Let's consolidate this into a simple, powerful tool that you can take with you right into the exam.
Okay, this slide right here is your cheat sheet. This is the whole thing. You need to memorize this simple decision tree. Step 1, just ask yourself, is the bond at a discount or a premium? If it's a discount, the seesaw tilts the yields up. The order is always coupon, then current yield, then YTM, then YTC. If it's a premium, the seesaw tilts the yields down. The order is the exact reverse. Coupon, current yield, YTM, YTC. And if it's at par, it's flat. They're all equal. That's the entire model.
And hey, don't just take my word for it. Tutors like Ken Finnan literally tell their students to jot this exact relationship down on their scratch paper, their dumb sheet, the second they sit down for the exam. It is a proven strategy to turn what seems like a confusing question into super easy points.
Understanding the seesaw also helps us nail another critical concept: yield to worst. Regulations require that firms quote the most conservative, or worst case, yield to a client. So for a premium bond, what's the worst thing that can happen? An early call that speeds up your loss. So yield to call is the yield to worst. For a discount bond, the issuer has no reason to call it. So the worst case scenario is just holding it to maturity, which makes yield to maturity the yield to worst. See how it all connects?
So let's circle all the way back to that first question. An 8% bond is trading at a premium. Which yield is the highest? Well, using our seesaw, you instantly know the price is up, so yields are down. And the highest yield has to be the coupon rate. Boom, done. But while you've now mastered the relationship between the yields, there is one of them that you absolutely must be able to calculate for the exam. Do you know which one it is?